My name is Evan Hamaoka, and welcome to a series about AP Computer Science A. This is our third video in the series, and today's lesson will be about loops. Loops are another fundamental concept in Java. They simplify coding immensely by iterating code, which is defined as performing a task or function repeatedly, looping. For example, if you wanted to print every number from 0 to 20 to the console in ascending order with only print statements, you would need 20 different print statements, and this would take up lots of time to write such a class, not to mention the inefficiency of such data storage. Alternatively, you could accomplish this with one loop with a print function inside of it. There are two main types of loops we'll cover in this course: for loops and while loops. Oh, and one thing before I explain how loops work. The loops in these videos, you can see here, are color-coded for your viewing clarity. They do not actually have these kind of colors in Java, so you look at the actual coding window here in Eclipse. Alright, so without further ado, here's a very simple for loop in Java. For int I equals 10, I is less than 50, I equals I plus 10, system.out.print I. So first, the code in blue is called the initializer, and it's run first. The integer variable I is declared and set to 10. Oh wait, we put semicolons after the first two, not the last one. We'll get to that later. Okay, so we put a semicolon after int I equals 10. Secondly, we insert the code in red, which is a stop condition. I have to call it a stop condition because it's, I don't know, it's red, it looks like a stop sign. You have to stop and check it before proceeding in any sort of loop. And so we check it, is the value of the variable I less than 50? 10 is less than 50, so yes. While the code in red is true, the loop will proceed to the next step down here. If not, the loop ends or terminates. For the next step, we jump down the line to the pink code. The purple code is here, and though it's on the same line as the red and blue code, it will be executed later after the pink code. So anyway, the code in red is true, then the pink code is executed. The value of the integer I is printed to the interface, which is 10. 10 is printed to the interface. The first looping prints out 10. Fourthly, the purple code is evaluated and executed. 10 is added to the integer I, making I now equal to 20. Importantly, nothing is printed on the purple step, not yet. After this, we loop back to the red code, the stop condition. We stop temporarily at it and look around and check that it's still true. Is the value of the variable I now equal to 20, less than 50? Yes. So we print I again to the interface, which is 20. The second looping prints out 20. And we add 10 to I when reaching the purple code again, making the value of I 30. We repeat this until the stop condition is not met. Question: what is the highest number that will be printed to the interface? Well, here I will demonstrate that code actually run Eclipse. So here we have the public class to make it work, the static void to make it work, and then the code I talked about earlier. And so once we run this code, the answer, as you can see, is 40. 40 was the highest number printed. Why is 50 not printed? Think back to the stop condition up here. After 40 will be eventually printed to the interface, 10 is added to 40 on this step, making I equal to 50. The stop condition checks now if the value of the variable I is less than 50. 50 is not less than 50, it's equal to 50. And so it terminates the loop. Watch out, the computer science AP really likes tricking people on technicalities like this. But what if you wanted the number 50 to be printed out? What if you wanted the printout to be 10, 20, 30, 40, 50? What would you do? Well, only changing the stop condition. Well, think about it for a second. Well, you would change the loop so that the stop condition looks like this. I is less than or equal to 50. And so once we run this, it should print 50 as the final number. And it does. Here the loop stops when I is less than or equal to 50. That was good. Okay, yeah, and one big thing. Let's slow it down here so that you can really understand this. Do not put a semicolon after the final code in the for statement. Repeat after me. Do not put a semicolon after the final code in the for statement. See up here, a good for statement looks like this. For parenthesis, int I equals 10, semicolon. I is less than 50, semicolon. I equals I plus 10, no semicolon. And then you print whatever's in there, down there. You do not do for int I equals 10, semicolon. I is less than 50, semicolon. I equals I plus 10, semicolon. Don't do this. This is bad. If you want to know what happens, it's a command for the interface to literally print nothing. Nothing. I've done this by force of habit so many times, so don't do this. Just the top one is good, the bottom one is bad. Now on to while loops. While loops are similar to for loops and will operate while a certain condition is fulfilled, the red code. When the red code is not true, the loop will stop or terminate. And the same color codes apply here. And so the blue is the initializer, so int n equals 10, semicolon, and then the red is again the stop condition. And you have to put the word while before in this stop condition. So it's while parenthesis stop condition parenthesis, and then as long as that is true, while that is true, the code below will run. So as you can see, this one prints out n every time the loop is run, and then after the loop is run, n has 5 added to it each time, and then it loops back to the beginning. See, it's not too different. And so for this one, it'll print out 10 for its first step, and then add 5 every more, printing out like the next increment of 5 every next step. And so as you can see in Eclipse, the highest number on this one printed will be 45. Yeah, it doesn't reach 50 because when it reaches 50, 50 is not less than 50. It's equal to 50, so it won't print. It's a lot like the first loop we did. And so back to while loops. Infinite loops are a problem. Like while loops can potentially be infinite, or it's a lot easier for while loops to be infinite, and this is definitely a problem. Because, okay, well, let's look at this one. So in this one, we initialize int n is equal to 10, semicolon. And so while n is less than 11, we print the phrase, forever, don't you feel like we've been doing this? And then n has 1 subtracted from it each time. And so, yeah, first we initialize, second, the stop condition's checked, and then n is 1 subtracted from it. 10 minus 1 is 9. 9 is still less than 11, so the code in red is evaluated as true. We'll go back to printing the phrase, don't you feel like we've been doing this forever? It iterates one more time. The value of n becomes 8. 8 is still less than 11. You see where this is going? Like, it won't ever reach the stop condition in the parentheses next to the word while. And so I will not run it right now. You do not want infinite loops because like they will keep printing the phrase again and again to infinity, or at least until Java crashes. Like if I printed this one, it would freeze and overwrite on my computer. And so, yeah, just don't make infinite while loops. But it's easy to, but just check your conditions to make sure they actually stop at some point. Okay, now for the hardest part of this unit, nested loops, or how does one loop run inside of another loop? And so to answer that question, the outside loop loops the inner loop. So nested loops obviously add another layer of complexity to the concept of looping, but they're incredibly useful. In essence, here's the kicker. Every time the outer loop is run, the inner loop runs to completion. And so here's a pretty good and relatively concrete example of a nested loop, taken from programiz.com. It establishes a day and week counter for a 2-week period, printing the week number and then numbering its days afterward. And so as you can see, it's here, it establishes there. It is a for loop with a printout, and then inside that we have another for loop with another printout. And so I wrote that in Eclipse, so I'll go to it now. Also, fair warning, I'm going to break it down, and this breakdown will be really, really painstaking and agonizing. So if you understand this, feel free to skip ahead to like the next part of the video, but here goes. Here are the steps of this nested loop. Okay, before either loop is run, we set 2 variables, like as we said before. The inner loop weeks is set to 2, and the integer named days is set equal to 7. Now we can run the loops. So first, the outermost loop runs, this one. In this case, it's a for loop, so it runs the same as we did before. So if we move, so like the code initializers run first, I set equal to 1. Here a new integer I is established, and this represents a counterfill loop. And so then we move on to the stop condition. The I less than or equal to weeks? I is 1, weeks is 2, so yes, it is. We continue. And then this code is executed printing week space I. And so we have week 1. That's the first thing in the printout. And then so after this, then we add this. We add 1, making I equal to 2. We don't worry about that now, because we have to go down to the inner loop before doing anything more with the outer loop. And so what does the inner loop do? The inner loop is also a for loop. And so this code, the initializer is executed first, and j set equal to 1, and then it's a new integer establishment. And so we check it against the stop condition. Is j less than or equal to days? The variable days is set equal to 7. Is 1 less than 7? Yes. And so we print out day : 1 to the interface. And then, but we have to run this loop to completion until it can't run anymore, this inner one, at least. So we check that again, and so we add 1 to j, and j becomes 2. Is j less than or equal to 7? Yes. And so we print out, day : So, day colon 2, day colon 3, day colon 4. We run it again, day colon 5. We run it 5 times now, day colon 6. So we run it 6 times now. And then for on the 7th one, we do day colon 7, and that's the printout. And then after that, we add one more to j. J becomes 8. 8 is greater than 7, and so that violates this. And so we stop running the inner loop, and we go back to the outer loop again, where now I did this step early, but I equals 2 now. And so we go down to this print function, and we print out quote week, end quote, plus the value of I. And so that becomes week colon 2. And then we do the same, the same thing done here is repeated again. All right, so it by definition, it's the same thing. Nothing has changed in the inner loop. So it prints out the same pattern of days. It runs 7 times. This is just me taking notes on it. 7. All right, and so at the very end, it reaches the same kind of end stop condition, so to speak. Like after during week 2, when the 7th day is reached, and then on J++, we change 7 to 8, and then now that doesn't meet the stop condition anymore, because days is equal to 7 and 8 is greater than 7, and so this loop terminates. But then once we get to this loop, we did I++ on the value of 2, so now I is equal to 3. So I is greater than or equal to the value of weeks. 3 is greater than 2. And so we can't run this one anymore. And after we can't run the outer loop, the inner loop can't run anymore. And so this will be our final code output. So it'll be like just week 1 with days numbered like this, and then week 2 with days numbered underneath. And because when the stop condition of the outer loop is reached in a nested loop, the whole loop stops. And so we can check that here. It should work. All right. Yes, there it is. And so those are nested loops. They're not too bad. They just require a little bit more thinking. Okay, now some time for some practice problems. So loop practice 1. Question 1, this is an AP problem in the book I'm reading. I consider it medium difficulty. So consider the following code segment. For int I, it's annotated. It's initialized properly. So for int I equals 200, semicolon, I is greater than 0. I equals I divided by 3. If I modulus 2 equals 0, we print out I with a space. So what is the output as a result of executing the code segment? So I wrote it in Eclipse so we can walk through it a little bit. So we start with int I equals 200. And so we check that the 200 modulus 2, well, 200 is an even number, and so 200 modulus 2 is 0. And so we print out our first I, which is 200. And then so we check that again, we run it again. 200 divided by 3 is 66.6 repeating. But since this is an integer loop, we're not casting, we're not working with any doubles at all. So 66.6 repeating truncates to 66. We check down here, 66 is even, and so it prints as I here. So we take that 66 back to the top, and so 66 divided by 3 is 22, which is even, and we don't even have to truncate it this time, and it also prints. And we're still greater than 0, obviously. But then for the next time, we do 22 at the top. So 22 divided by 3 is 7.3333, which as an integer truncates to 7. And 7 here is odd, so that it doesn't print. However, we keep 7 as our I. And so we take 7 back to the top. 7 divided by 3 is 2.333, which we express as 2, which is even, so it prints. And then we do it one more time, then so we do 2 divided by 3, which is 0.666, but that truncates to 0. And then that violates the stop condition here, as we don't keep running as long as I is greater than 0. Now I is 0 because of integer loop truncation, so it doesn't run. And so our expected printout should be 266, 22, and 2. I'll just notice that this is a print ln, so it should print on, like, it should print with one number per line, but let's check it out. Great, it printed as expected. Okay, so practice problem number 2. This is an AP problem from my AP book. It's pretty hard. It's actually really evil. It's a triple nested loop. And so if you can solve this one, you really understand the concept well. So the question is asking, what is the value of A after the code segment executes? And so if you think you can do it, pause the video. If not, I'm going to walk through it. Okay, and so the first thing to notice is like, okay, so what is the loop actually asking? And so the question is actually asking how many times the overall loop, all 3 layers will run. So because A functions as a counter inside the innermost for loop, which is inside a for loop, which is inside a for loop, int A equals 0. This just initializes it as 0. And so every time the inner loop runs, which is dependent on the outer 2, A will have 1 added to it. And so, all right, so notes. The outer loop starts at 0. So we have to check the conditions of the outermost loop, this one here. So the outer loop starts at 0 and stops when I isn't less than 10. So in other words, it will count from 0. It'll add 1 every time. So it'll go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It won't reach 10 because of the stop condition here. Like, because it's less than 10. It's not equal to 10. So when it goes from 0 to 9, it will run 10 times. So outermost loop runs 10 times. And so we have to check the first inner loop, this one here, that one that deals with integer k. So int k equals 0, k is less than or equal to 5, and k plus plus. And so this loop will be evaluated 6 times for every time the outer loop, this one, is evaluated. Why 6 times? Well, it starts at 0 and goes from every time it counts up here. So it goes from 0, 1, 2, 3, 4, 5, and it reaches 5 because the stop condition is inclusive of 5. It has the little equal sign there. It's important. And so it will, the middle loop, the one with k, will run 6 times. Middle loop runs 6 times for every run of the outermost loop. And then so we have to go to the innermost loop now. So the one involving z. So here we can see that it initializes z as 1. The value of z starts at 1, and it doubles every time the loop is run. So the body of the innermost loop will execute when I equals 1, I is 2, I is 4, I is 8, and I is 16, because there's the equal sign here. When 16 equals 16, the loop will still run. So 5 times innermost loop runs 5 times for every run of the middle loop. You got that? All right. So we see the outer loop executes 10 times. The middle loop executes 6 times for every time the outermost loop is run, and the innermost loop runs 5 times for every time the middle loop is run. And so what is that? So that's 10 times 6 times 5, which is equal to 300 iterations. And okay, so we can check that here. That should be right. Yes, the loop runs 300 times. All right, I'm feeling a little bit loopy about that. All right, and then we can go to the last one. This is very difficult, so I'm not even going to read it. What is the value of A after the code segment executes? Is this a trick question? The answer to that is yes, this is a trick question. And so once we can look at it in Eclipse here. And so we have the 2 things that make it work. We have a class declaration, we have a public static void here that needs to be in every class. But then, so we set int a equal to 0, and then we have these 3 for loops, but they have colons at the end, semicolons at the end. What does that mean? That means these loops don't yield anything. These just basically aren't there. So even though they look extremely confusing, this problem is very tricky. And so it'll ignore all this for int a, and it'll just print, okay, a will have 1 added to it here because of a++. And then so once we print out a at the bottom to prove it to you, it prints out 1 because all of this craziness was ignored, and it just goes to this. See, that wasn't too bad, was it? It's just a trick question. And so anyway, that concludes our YouthSTEM lesson about loops. I hope you enjoy it. This is video number 3. Thank you.